Welcome to the Context Minute, where we break down the big stories.
So today, we're going to talk about something pretty wild, the surprising link between artificial intelligence and a comeback story for, wait for it, nuclear power. Yeah, you heard that right. We're looking at how these tiny little reactors might just be the key to solving a massive, massive problem. Let's just start with a number that's kind of hard to wrap your head around, 6.6 gigawatts. To put that into perspective, that is a ton of power. And that's how much nuclear energy the tech giant Meta is working to lock down. And the reason? All to feed its incredible, and I mean incredible, ambitions in AI.
So, that brings up a really big question, doesn't it? Where is all of that power going to come from? The AI revolution needs a staggering amount of electricity, and not just any electricity. It has to be clean, it has to be completely reliable, running 24/7. Our current power grid, well, it just wasn't built for that kind of demand.
All right, let's break this down. First up, we need to understand AI's absolutely insatiable energy problem.
So you've got these giant companies. We're talking Meta, Google, all the big players. And they're in this crazy race to build what are called AI superclusters. Now, these aren't your average data centers. Nope. They are giant warehouses, just packed to the gills with powerful computers guzzling electricity. This is putting a serious strain on our power grids, forcing these companies to look for their own private power plants, something totally dedicated, clean, and reliable around the clock. Because for AI, the power can never go out.
And, this incredible demand for energy is actually breathing new life into a technology that a lot of people had, well, pretty much written off. It looks like we're witnessing a new nuclear renaissance.
So how did this happen so fast? Well, a really big push came in May of 2025. A series of executive orders were signed with one specific goal: to revitalize the American nuclear industry. The whole plan was to slash the time it takes to get a license, boost domestic fuel production, and just, streamline the whole regulatory process. This basically rolled out the red carpet for new advanced nuclear tech to step in and meet this surging energy demand.
But here's the twist. When you hear nuclear, you probably picture those giant, iconic cooling towers, right? Well, that's not what we're talking about here. The solution on the table is something way, way smaller. Let's meet the microreactor.
Okay, so the technology at the heart of all this is called a small modular reactor, or SMR for short. And the idea is actually pretty brilliant. Instead of spending, a decade or more building one gigantic custom power plant on site, what if you could just build smaller reactors in a factory? Kind of like on an assembly line. Then you can just ship them wherever they're needed. It's a total game changer.
And when you put them side by side, the difference is just, wow. A traditional plant, sure, it can power a whole city, but it's this huge, one-of-a-kind construction project that takes forever. SMRs, they are a fraction of the size, can be built so much faster, and you can put them in all sorts of places, which makes them a perfect fit to power something like a dedicated data center campus.
Now, let's look at a real-world example of this. There's this company called Oklo, and they've developed something called the Aurora Powerhouse. It's a genuine microreactor. It kicks out about 15 megawatts, plenty for a large factory or even a small town. But here is the most incredible part, the really mind-blowing feature. It's designed to run on what we currently think of as nuclear waste.
And that really gets to the core of what they're trying to do. You can see it right here in this quote from Oklo CEO Jacob DeWitt. He says it's all about demonstrating how they can repurpose used nuclear fuel. I mean, think about that. They're trying to take this problem that we've been stuck with for generations, nuclear waste, and turn it into a source of clean power. It's like the ultimate recycling program.
Okay, but that, of course, brings us to the elephant in the room with any kind of nuclear technology, right? What about the waste?
And, well, the answer isn't super simple. It's a bit of a mixed bag. See, while these advanced reactors might create less waste in terms of sheer volume, the waste itself is different. It's all about a trade-off that revolves around this idea called burnup.
So what is burnup? The easiest way to think about it is like squeezing every single last drop of juice out of an orange. These advanced reactors are just way more efficient. They get a lot more energy out of the same amount of fuel. That's fantastic. But the stuff that's left over, the waste, even though there's less of it, it's initially way hotter and more radioactive. So that means we have to come up with totally new ways to handle it and store it safely.
Okay, so let's tie this all back together. How does this connect to AI? Well, this is the part of the story where things went from just being an idea on a whiteboard to happening in the real world, and it happened fast.
Just look at this timeline. It's wild how quickly everything happened. You've got Oklo getting a big green light for its fuel facility in November 2025. Then boom, just a few weeks later, in January 2026, Meta drops this bombshell announcement about deals with 3 different nuclear companies. A few days after that, we start to see just how huge these plans are, and before the month is even over, the government is already passing funding to keep this whole thing moving. It's an incredible pace.
And here's what it all led to. This isn't just talk, this is real. Meta and Oklo are actually moving forward on a massive 1.2 gigawatt nuclear power campus in Ohio, and its entire purpose is to power AI data centers. This is a huge deal. It's basically the first time we're seeing big tech go all in on a brand new energy strategy like this.
So there you have it. These tiny, powerful reactors could literally be the key to unlocking the future of AI. They promise clean, super reliable energy that you can build right where you need it. But it also means we as a society have to get on board with a whole new generation of nuclear technology, which comes with its own very serious challenges and responsibilities. And that leaves us with one big question. Are we ready for that?
Thanks for spending some time with us here on the Context Minute. We'll catch you on the next one.